Hi, my name is Laila, and I'm going to present you a second tab in our app, which is called Many-Facets Rasch. So this tool extends the functionality of the Uni-dimensional Rasch analysis to include an examination of item bias. This form of analysis provides insight into how some questions or developmental criteria might function differently across student groups. The tool also takes an item response matrix, which is a spreadsheet of student test results. Though the tool requires that the first column specifies the binary facet of interest. For instance, column header gender. The variable needs to be numeric with coding 1 representing male, for example, and 2 representing female accordingly. The report includes and produces a detailed, narrated technical report and organized spreadsheets that reflect the function of the test and each question, as well as a report on item bias. I'm going to show you an example of the data that the tab takes. Here it is. So the first column is the facet of interest or a student grouping variable. It could be anything, but in this case, it is named female. Therefore, as a rule, females are coded as 2 and males as 1. So, as you can see, there were 1,000 students in the test. Some of them were males and some of them were females, obviously. And the second column, so starting from the second column till the end, is the item response matrix for the test results for each student, where ones stand for the correct responses and zeros for the incorrect responses. So we can see that there were 10 items in the test. So 1,000 students gave their responses to 10 items. So as for the settings, we should use the same settings as for the first tab, which is called Uni-dimensional Rasch. Let's go to our second tab. And yeah, so here we can specify a topic for example, algebra, and the focal group, which could be grade 7 students. These settings should be the same as for the previous tab. And in addition, there is the option for flagging bias items. This is at step 6. To flag possible bias items, we need to set a threshold. If the difference is 0.5 or more, the item is flagged. Also, we can set the level of statistical significance. This is commonly set to 0.05 or less. And then we can run the report. Here, how it looks like. So first of all, a zip file is produced, and then we can inspect it. Here we find the description of the general methodology and mathematical model in section 3.4.11. Here it is. And the results themselves are presented in Appendix A8, which is on page 52. Yeah, okay. So we can focus on the bottom half of the table. We can see one result that is both red, statistically significant, and blue, practically significant. This is question I0006. We can see that being female is associated with an easier item difficulty. We can therefore inspect the item, perhaps present it to colleagues, and consider how it may advantage female students or vice versa, disadvantage male students. This information may inform possible improvements to the way that questions are formatted and presented to students in the future. Thank you for your attention.